I hope this is working on the right slide. I got sent a quick message earlier this morning from Nurhat. He wanted me to have a look at this exam question. I'm not sure which paper it's from or when, but he seems to be having some problems resolving forces. So, quick way to go through solving these sorts of problems. Let's first start drawing the result, the forces acting. So we've got the tension pulling that up, we've got its weight pulling down. As the weight's given us 4G, I'm going to say that the weight is going to be 4G as newtons, so we'll be working purely with the particles as they are. Other forces we've got in here is the reaction at A, and we need to add friction to this. Now, the thing to note is the system is in limiting equilibrium, given that P is on the point of slipping down the plane. So limiting the equilibrium means that the whole of the friction is acting. So FRA is a maximum. So what we've got then to do is work through and say, right, if that's been done, which way is it working? Well, they said that A is about to move down. So at the moment the velocity is trying to go that direction, but the velocity is actually 0. But it's at the limit. Friction always tries to go against motion, not necessarily acceleration. And this leads us to having a friction up the slope as well. The friction is trying to stop it moving down the slope. That leads me to create a motion. I'm going to equate my forces, so the net force is 0. So equilibrium at A. At A means the forces must balance. There is no net motion yet. So I'm going to say positive is up the slope, so we're actually doing motion positive on the slope direction. So things trying to pull me up is my tension, my friction, and what's trying to pull me back is the weight parallel to the slope. So it's W1. Given that the angle is here, is A, is alpha, that means the alpha must be here by similar triangles. So what we've got pulling us back is 4G sine of my alpha. They get told as a tan alpha equals 3 over 4, which tells me sine alpha is 3 over 5. And that's by 3, 4, 5 triangle, which you keep forgetting. Okay. Give us an expression for the tension then. So we use the tension, and the tension is going to be, rearrange it. So the tension now equals the 4G sine alpha, so that's 12 over 5. 12 over 5 before G. That's my weight. Subtract the friction. Friction is a quarter. Friction, quarter of my force. I forgot to take into account the reaction force. We need to calculate the reaction as well. So the reaction is going to be the W cos alpha. Just finishing one question off. W cos alpha. So that's going to be 4/5 of 4G. Cos alpha. Cos alpha is 4/5. 4/5. Yeah, 4/5. of 4G. So this leads me to have a tension of 5 Gs. On the second side then, we also have on the other form, we've got a B. They said it's smooth, and that leads us to have a mu B of 0. Do the same motion, so B, weight down here, we don't know what it is, mg, the angle beta will be the angle between the force and that angle there, and we've got the tension pulling up. So again, we've got no motion, it's not quite moving yet. There is no friction because of this mu r, so we don't even need to worry about the r for B at the moment. So the friction is, we're going to say tension, positive, and we're going to subtract the sine of beta times mg. So put all the equation bits together, I've got 8/5 of g, taking that to the other side, sine of beta, tan beta is 4 over 3, so sine of beta is 4 over 5. So we're going to get 4/5 mg, which leads to a solution and it's 2 kilograms. And that's that question completed.